I'm still fighting with this spindle, and here is that bigger ram that I mentioned last time. This one will get us up to a full 20 tons of persuasion in the right direction. It's a bit of a different style to the bottle jack from before, so we need to make some adjustments to my frame before any pressure can be applied. Recently though, I've had the part in the forge again for several heat and cool cycles, and I've been constantly dousing it with penetrant. I'm not really sure if it's been doing anything, but it made me feel better. Anyway, let's see if it's made any difference. It's moved. It's moved. It's moved. Getting to about 10 ton and then clicking. Well, something's clicking anyway. The small flurry of movement was short-lived because now all I'm doing is making scaffold bananas. After watching back this footage, I realised the ram was wanting to nosedive because of the less supported lower crossmember is slipping back, and that is what's causing the horrific bending. Some scrap welded to the steel behind the crossmember should solve that problem. And it really did, because I was able to build up to a much higher pressure and got a bit of a jump. Unfortunately, not all of that jump was movement in the part, as it was obviously time to replace the front cross members. The little cutout was there originally to provide clearance for the spindle, obviously weakening the steel section. But now, because of the movement we've had, I no longer need that clearance and I can replace it with a new piece. And it's time to build up some more pressure. So this is not going well. This is still winning. It's got so far and obviously bound up on something because it is just not shifting anymore. Just bent another piece of scaff tube. Running out of ideas really. What it wants is some shot, but it's a tricky one to get to it. It's so long, there's so much distance between there and there. It just wants to flex in the middle. So what it wants is a good old hammer. In the frame, unfortunately I had bent the top of the spindle slightly. Although not irreparable, it had made me want to try a different method. After all, it was the big hammer that finally got the column moving. So I was hopeful. I've also borrowed a bigger torch from a friend, which will allow me to pump a lot more heat in much quicker. It's moving. That's 7 inches there. It was just above 6 when we started, so we're about 6 1/4 inches, so it is moving, just very slowly. I bet now if I shove this down the keyway, where is it? Yeah, there's a lot of rubbish in there that's compressed. It's going to have to be a very, very slow, steady job. So letting it cool down a little bit between each heat to maximise the expansion, and then we'll go again. Come on! Even though it has moved, it was clear that the gains were completely outweighed by the effort and gas consumption. I was also just driving the frame slowly into the yard, and it was time for yet another plan, which is to try and remove the key that drives the spindle. So I'm going to cut this key out from above, or try. This is the top of the key here. It's fitted from inside, and there's a little wing each end of it which holds it in position. I'll explain that a bit better later. I've calibrated my machinist level to read level with the table of the mill, and then by placing that on this exposed piece of keyway, which is nice and fresh because it's just come out, we can see how level or not this whole thing is. So I'm just going to tilt it towards me. Oh, a bit far. So each red line on that level is 1/1000 of an inch rise or fall across the 6-inch length of this level. So it's a really good level for this kind of thing. To set up this existing keyway perfectly level with the table. Cool. That's probably as spot on as I can get him, so I'm going to tighten these clamps down. First thing we're going to do is line up the cutter with this keyway and touch off in the bottom. So I'm going to lock my cross slide now. Happy with that. And I'm going to raising the knee slowly until we get a little tickle on the bottom of that keyway. I just set that DTI there so I can remember this knee position is the bottom of the original keyway. So if this is our spindle and set a certain distance into it is a keyway, surrounding the spindle is our quill, bearing, journal, part, whatever you want to call it, tapered bearing there and then there as well. Then in this area there's a slot cut in that quill piece like that. Inside there is a key, which is what we can see from the outside, and I assume, I'm not entirely sure, but I can't see any other way of doing it, that key extends into the keyway, obviously, but also sticks out slightly, that side and also that side. So basically what we've got is this T-piece, which is forming the key and driving the spindle. Now this piece would have been fitted from inside the quill and then popped up into this hole in the quill. It's the only way I can see they would have done it. So what I'm doing here is milling away all this material until we get down to somewhere near the bottom of that key, and in theory that should release these two wings and they might drive out the bottom, they might be able to pick up from the top, I might not be able to get them out at all, but the idea is that it should release some of the pressure and aid us on our way. So we are extremely close, so I'm just going to pull him out and do a bit of an idiot check. Check nothing's shifted, see if he still lines up with the keyway. And it does. I'm going to check my DTI still reads true. We're through! No way on earth you're going to be able to see that, but trust me, It's like very thin, flaking up from the bottom. 10 thou short of my target as well, so we were pretty close. Always nice when the numbers work out. And right down there is our original keyway in the spindle. Right, now what? Now, was that causing us to bind up? I don't know. Let's see if we can get the other side out. Right, what's stopping you now then, buddy? With the key safely removed, it started to move quite a bit more under the hammer, until it bound up again, and I decided that it might be worth giving the hydraulic ram and frame another go. Surely now, with no key to bind up, a 20-ton jack, a big torch, and clearance for the bearing to sit the other side of the cross members, it would come out easily, right? I built it back up to pressure, applied heat, and it did move, about 3/16 of an inch, as shown by the steel rule. By now, I had come to terms with the fact that this was not going to be a quick process, and had a system that was producing the right result, albeit slowly. So I settled into a bit of a routine: build pressure, heat, move 3/16, build pressure, heat, move 3/16, pressure, heat, 3/16, then allowed to cool. I did this 3 times a day over the next week, and slowly but surely the spindle emerged. I did cause a nasty bend at one point, which I had to straighten in situ. The spindle was already bent from that previous attempt, so some careful straightening will be required after removal. Also, I was just about ready to cut this up and make a new one at this point, so I wasn't overly concerned. Even so, determined to save as many original parts as possible, I persisted. you next time.